Okay, so we have exported our Gerber files, we have zipped them up into our zip folder, we have found where that zip folder is. Now what we want to do is get a prototype design for the board that we've done. Obviously we don't want to just immediately throw that in and cook up 10,000 boards, because we may, in fact we probably have made a mistake somewhere that we need to discover during the prototyping iteration of the design. Okay? Now this, nowadays, the last 5 or 10 years, there's been a seismic shift in how we do this. When I started with electronics, and probably Dr. Woods as well, we never had the option to be able to send our design off and get a prototype board back for any realistic price of money. Okay? What we'd have to do is we'd either have to bite the bullet and make 100 or so and pay the price for it, and then if we find our mistakes, fix our mistakes and go through that iteration again, or we'd have to cook our boards ourselves. And if it was a simple board, we could do that. We could get a little etching station, we could buy a copper clad board, you can still buy them now. You can use ultraviolet to transfer a design onto your board, and then you can put that in ferric chloride, wasn't it? If I remember.
Ferric chloride, yeah.
Ferric chloride, and the ferric chloride would dissolve away the copper that hadn't had your design photoed onto it. What's the word for that?
Photolithography.
Photolithography, that's it. Where you would print your design on a transparent piece of plastic and then fire an ultraviolet light through there in a little light box, and you would see your design transfer onto the copper. Those days are fortunately gone, and now we've got this ability to be able to send our design off, and for very little money we can get 5 boards back, 1 board, 10 boards, and we can work the prototype. Now there's a ton of companies out there now that will do this, and we just use PCB Way because they're very well known, they're very big, and they can spin the board very quickly and very cheaply. And the reason they do it cheaply is because they buy their copper clad boards in an 8-foot or 10-foot by 8-foot sheet, massive sheets of this copper clad board, and they take everybody's prototype and they put them all on this same board and process the whole lot as one PCB. So therefore the entire cost of running one board through their fab plant is shared between lots of different customers, all seeking a few boards for their prototypes. Yeah? That's how they get the price down. So we pop up our Internet Explorer or our browser, we search for PCB Way, we then jump into PCB Way, and at this point you will have to, if you don't already have one, create an account with PCB Way. It's free, you just need an email address. If you've already got one, great. If not, that's the first thing you've got to do. Okay? Once you've created your account and you've logged on, what we can do is we can go to this PCB Instant Quote option just here. And then we, in this particular case, just for the simplicity of this module, we will use a standard PCB. There's obviously lots of other options if you're doing high frequency or flexible or whatever, but in our case we're going to do a standard PCB. Our board type, what the board type refers to, is typically in a production environment, your board is going to pass through, once you've got your boards back, they're going to pass through other processes, for example pick and place, where the components are put down, SMT reflow, where it goes to an oven and everything gets soldered, all this kind of stuff. So you wouldn't have a single board. You wouldn't be able to place a single board through a machine, so you would have a panel. What's known as a panel is very standard. And what a panel is a huge PCB that consists of a border, and inside this border are lots of your designs. So your board is stepped up at a particular quantity determined by the size of your PCB. So each panel will have a number of your boards on. Yeah? And this panel, the measurement of this panel is what will go through the other machines in the manufacturing and fabrication process. Okay, and they'll typically have a fiducials on so that the CNC machines from different place can find their point of origin, etc., things like that. And then this would be the same board many times, yeah? Everybody clear with that? So typically that's what will happen in a production environment. But when you're doing a prototype, we have a single piece. We don't have a panel. The other options are we can create our panel ourselves, or PCB Way will panelize it for you. So if you ask PCB Way to do 1,000 of your boards, then you could get them to make this panel for you so it's ready for the further fabrication processes. So in our case, we've got a single piece, and we've got one design. Right? Why is it asking this question? If I want 2 or 3 different designs of a board, I could get them all on one panel that PCB have made for us. Yeah? Again, it's just a prototype. Then the next thing, and this is very important, is asking what's the size of your PCB? Yeah? What is the size of this PCB? How do I know? So the easiest way to do that, yeah, is we can go somewhere. What we can do is we can place a dimension, a standard dimension, a horizontal dimension, a vertical dimension. So let's go for a horizontal dimension from here to here. Right, and then I can place a vertical dimension from here to here. So you can see that this board is about 48.2 millimeters in height and 56.3 or 56.4 millimeters in length. So I need to tell PCB Way that. And what I'm going to do is I'm going to round that up. So I'm going to say 57 by 49. So I come along here, my length, I put 57 millimeters in there, and I width 49. Okay? How many do I want? In this case, I'm going to say 5, which is the minimum. How many layers is my board? And I refer you back to our previous discussion with the stack up. In this case, I've got 2 layers. So I'm going to select in here that my board's 2 layers. Okay? Now, typically you can leave everything else as default, but I'll quickly talk about it. FR4, I explained to you, in the stack up, the substrate in the middle, yeah, the insulator. Fiberglass typically is FR4. If you have a design that's very high in frequency, more than 2 gigs, typically, maybe even more gigs depending on the design, then FR4 will start to act like a component itself and start messing with your signals, in which case you need to use a different substrate. Yeah? But for this, we are using FR4. Now, this TG, right, this is the kind of fabrication that they're going to use to be able to design your board. So you can leave that as a default. I definitely would not recommend changing it. If you do, your price is going to go up because you're asking for a specialist service. Then it's going to ask you for your thickness of your board. There's a bunch of standards here. The most standard is 1.6 mil. Yeah, and that is the width of this FR4. Yeah, the width of that substrate is 1.4. But if it's a 4-layer board and you've got 2 substrates, then obviously they will deal with it. So your final board size will be 1.6 mil. Yeah, so then they'd have probably 2 0.8 substrates. Yeah. You can also choose something like 1 mil, that's also a standard. If you choose any of those other variables, your price is going to go up. Why? Because like I said at the beginning, how they're keeping this price down is by sharing their huge panel among lots of customers. Everybody's going to be typically wanting a 1.6 mil thickness board. So if you go in with another size, there'll be less customers who also want to have that size, so that then you will pay more for the panel to go through the fabrication process. Okay? So our standard is 1.6. And now, do you remember last week I spoke about your track spacings? Yeah, so you have a track and a clearance spacings and the minimums. So when you're designing your traces on your board and the clearances between the traces, they need to adhere to these minimums. Yeah? And the default is 6 and 6 mil. That's not millimeters, that's MIL, so it's fab. Yeah, so it's thousands of an inch. So what that means is it's 6 thou by 6 thou. Yeah? If you go smaller than that, again, the price is going to go up because they need to use much more precise etching fabrication techniques to make sure that none of the tracks short circuit. Okay? So again, leave it on the minimum. Minimum hole size, if you're drilling holes for through-hole components or anything like that, if you go less than 0.3 millimeters, your price will go up because they create more drill bits when they drill it. Yeah? So when they're going on board, they will put it in a CNC drilling machine and lots of drills will come down and drill. And you can imagine if they're really small holes, they're going to start breaking. Or if they're really, really small holes, then they'll use lasers or something like that to fire through, and it's a more expensive process. Then, what colour do you want your solder mask? Your solder mask layer, remember that? Typically it's green, but you can choose a different colour as well. Your silk screen, that's the text on top of it. What colour do you want that? And surface finish, okay, so you might have a specific surface finish, like they want a lead-free finish or something like that. In our case, leave that as a default, because again, it's just going to push your price up. And it very much depends on the country that you're targeting and all this kind of stuff, and the regulations that involve as to whether you're allowed to use lead or not. Okay, tenting vias, plug vias, or vias not covered. What does that mean? Or vias? You know, I spoke about these vias up here. When they connect the copper between the different layers, then there's a top and a bottom that's exposed. Yeah? And when I say exposed, you can see the copper. What do you want to do with those, as they say? If you want them tenting, it means that they'll put some solder mask over it so that they're not conductive on the top. Yeah? If you want them plugged, then